Hello everyone. Now let us get to the next topic. So the next topic that we are going to see is called as networking devices. So we are basically going to focus on layer 1, 2 and 3. So now we are going to look at the various devices that work on various OSL layers. So we know the OSL layers are of 7 layers. First is called as a physical layer. Then we have the data link layer, network layer, transport layer, session layer, presentation layer and application layer. So in the physical layer, we have various devices like repeater, hub, you have amplifier, etc. that works on the physical layer. Then we have in the data link layer, we have devices like a switch and a bridge that basically operate at the data link layer. In the network layer, we have the device called as router. Router works basically at this layer. And then we have the device called gateway, which basically operates on all the 4 layers like the transport layer, session layer, presentation layer, and application layer. So now in the coming slides, we'll be able to see the working of each device. So before that, let us get into the introduction. So in introduction, basically, we are going to see the topics like what is information security, computer security, and network security. So information security is basically, it is a set of practices intended to keep data secure from unauthorized access or alterations. Computer security, it is basically protection of the computer systems and information from harm, theft, and unauthorized use. Network security is a broad term that covers a multitude of technologies, devices, and processes. So, in simple meaning, we can say it is a set of rules and configurations that are designed to protect the integrity, confidentiality, and accessibility of the computer networks and data using both hardware and software. So network security for businesses and consumers. So network security should be given a higher priority for any organization that works with network data and systems. So in addition to protecting the assets and the integrity of the data from external exploits, network security can also manage network traffic more efficiently, enhance the network performance, and ensure secure data sharing between employees and data sources. Connecting devices. LANs do not normally operate in isolation, but they are connected to one another or to the internet. We know there are different types of networks. Basically, we have the LAN, MAN, WAN, and PAN. So when we're talking about all these networks, we'll be using a lot of connecting devices are needed. So these connecting devices are nothing but we can use bridge, switch, router, hub, repeaters, etc. And also we'll be using different types of cables to do the connections. So only after connecting all the various devices, we'll be able to transmit data from one device to the another device. So that is why these connecting devices are important, and we need to know the working of each and every device so that we will be able to use them. So first let us see what is a network device. So components that are used to connect computers as well as other electrical devices together in order to share the resources such as printers and fax machines are basically called as network devices. So first let us see what is a hub. So a hub is nothing but a small rectangular box that joins computers together through ports on the back of the hub. So here we have shown you an example of a 4-port hub where we are having 4 ports where we can connect 4 different PCs, or you can also connect 4 different devices to this particular hub. So here you can see the working of the hub, where in this diagram each PC will be sending the data, and a hub is basically a non-intelligent device, and the working of the hub will be always doing a broadcast of the data. So let us take for example, there are PC 1, 2, 3, 4. PC 1, if is sending some data, the hub what it will do, it will be broadcasting the data to all the other devices. Likewise, if PC 2 is sending some data, it will receive the data and it will be forwarding the data to all the other ports. So because it is a non-intelligent device, it does not know where exactly it needs to forward the data. So a hub will be always doing the broadcast of the data. So whenever we are using a hub, there will be more traffic in the network. So that is the main reason we go for intelligent devices like switch. where we can transmit the data only to the intended destination. So how does a hub work? A hub receives the data packets and passes on all the information it receives to all the other computers connected to the hub. That's what I told you about this. If computer 1 wants to communicate with the computer 3, the data will be sent to all the computers on the network, since hubs do not know the destination of the information it receives. So hub is operated basically at the physical layer. It is used to connect multiple computers in a single workgroup LAN network. So typically we get hubs of various sizes, like we can have a 4 port, 8 port, 12, 24 or 48 port hub. So based on the port type, there are two different types of hubs. One is called as the Ethernet hub, the other one is called as the combo hub. A Ethernet hub, basically all the ports will be having an RJ45 connectors, whereas a combo hub will be having different types of connectors like RJ45. It will also having BNC and AEY connectors to attach to the devices. So for example, a hub which has only 4 ports, ports share everything. So one port receives the data signal from its connected device. It will make 3 copies of the data signal from the hub and give 1 copy to each port. The receiver port doesn't need a copy of the data signals for itself, as it is having the original version. So that's what if I say PC1 is forwarding the data to all the other PCs. So it will be forwarding one copy to the all the other remaining PCs. So when a hub receives a signal on its port, it repeats the signal and forwards that signal from all ports except the port on which the signal arrived. So coming to the different types of hub, so you can also classify the hub either as a passive or an active hub. So what do you mean by passive hub? So passive hub means it will just forward the data signal from all the ports except the port on which the signal arrived. It doesn't interfere in the data signal. So whereas if it is an active hub, it also forwards the data signal from all ports except the port on which the signal arrived. But before forwarding, it will improve the quality of the data signal by amplifying it. So due to this added feature, active hub is also known as repeaters. Additional information about hubs. Most hubs contain 4 ports. Some have more than 5 or more ports. Hubs can be basically used for a smaller network such as a home network or a small office network. Hubs are not that expensive. Most range for less than $30. Hubs may not be the best option for sophisticated or complex networks. In case if you want to have a complex network, you have to go for advanced devices like a switch. If you want to do routing, we need to have routers, etc. What is a switch? Switch looks similar to the hubs in that they are rectangular in shape. Manageable switches are usually a little bigger than the unmanageable switches, and switch also has ports on the back. So this is an example of a switch. So coming to the functionality or the working of the switch, a switch is an intelligent device. So it will learn which PC is connected to which port number. For example, if PC A wants to send a data to PC B, the PCA will be sending the data to the switch. First time alone, the switch will be doing a broadcast of the data. But once it does the broadcast, it will learn which PC is connected to which port. And once it receives the information, the intended data will be sent to the corresponding destination alone. Okay. Only for the first time, the switch will be doing a broadcast. But after that, switch will not do a broadcast. It will prepare something called as a CAM table, where it will identify and map each PC is connected to which port number, and the next time onwards when they want to send the data, the switch will be sending the data to that destination. So how does the switch work? Switches work about the same way as hubs. Unlike hubs, switches can identify the destination of a packet. We know switches then layer 2 device, which is called as your data link layer. So switches send information only to the computer that is supposed to receive the information, and switches can also send and retrieve the information at the same time, which makes sending information faster to retrieve than the hubs. Switch. Just like hub and bridge, switch is also used to connect multiple computers together in a LAN segment. Switch operates at the data link layer. switch also comes in various ports. Like we have a 4 port, 8 port, 12, 24, 48 and 64 port. So each switch port has a separate collision domain. So a collision domain is nothing but, for example, let me take a 24 port switch. In a 24 port switch, I can connect one hub to a particular port. So in that hub, I can connect n number of devices. So if there is any collision happening in that particular switch port, it will not be transmitted to the other ports or other devices that are connected to the switch. So that is what we are telling. Each switch port has a separate collision domain. So at layer 2, data signals are formatted or forwarded in the frames. So when a switch receives the frame, it checks the frame check sequence field in it. Switch processes the frame only if it is valid. If it is having any invalid frames, they are automatically dropped. All valid frames are processed and forwarded to their destination MAC addresses. Switch. There are three different types of switching. So first one is called the store and forward switching, cut through switching, and the third one is called as your fragment tree. So now let us get into the first type, store and forward. So from the name itself you can understand. So it will store the data and then it will forward. So this is the simplest or basic idea. So this is a basic mode of switching. In this mode, switch buffers the entire frame into the memory and then it will run the FCS. So FCS is nothing but your frame check sequence. It will ensure that the frame is not having errors, to ensure that the frame is valid and it is not corrupted. A frame which is having lesser than 64 bytes and if it is higher than 1518 bytes are invalid. So only valid frames will be processed and all the invalid frames will be dropped. Among these three methods, this method has the highest latency. What do you mean by latency? Latency is the time taken by the device in passing the frame from it. Switch. Now the second type that we are going to see is called as a cut and through switch. So cut and through method has the lowest latency. So in this method, switch only reads the first 6 bytes from the frame after the preamble. So these 6 bytes are nothing but it will identify the destination address. So this is the fastest method of switching. It will just check where it has to deliver and it will be just pushing the data to that particular port. So this method also process invalid frames. So this is one of your disadvantage of your cut and through switch. Because invalid frames, if you look at the first method, it basically drops the invalid frames. So since it is reading very fast, so it is not checking whether it is valid or invalid frame. So it is also tending to process the invalid frames, so which is one of the drawbacks here. So only advantage of this method is speed, because it will just check for the destination and just it will push the data there. So coming to the next type is called as your fragment free switch. So this is the hybrid version of the store and forward method and the cut and through method. So it takes goodies from both the methods and makes the perfect method for switching. So it will check the first 64 byte of the frame for error. It will also process only those frames that have first 64 bytes as valid. Any frame which is lesser than 64 bytes is called as your runt. Runt is basically an invalid frame type. So this method filters the runt while also maintaining the speed. So this is an example of a switch network where we are having a switch. We have 4 different types of PCs that are connected here. So now let us look at the additional information about switches. Switches are a better option than hubs for a larger networks, and also the price range is between $30. You can have up to $100 or more depending on how you want to purchase. Either you can also go for manageable or unmanageable switches based on your need. So the next type of device that we are going to see is called as your bridge. A hardware device that is used to create a connection between two separate computer networks, or to divide one network into two, we use a bridge. So it will basically use to filter the data traffic at a network boundary and also reduce the amount of traffic on a LAN, dividing it into two segments. So this is an example of a bridge. So here we are having a sample scenario where we are having PC1 and we are having a PCB. So without a bridge, what will happen if PC1 is trying to send some data? So since it is using a bus type of topology, the data will be passed to all the devices. Even though they are the intended destination, they will also have to process the data. So there is unnecessary traffic that is being processed by the other PCs. So let us look into the. So bridge and networking divides the LAN into multiple segments. A bridge basically works in a bus topology. Okay, so in a bus topology, if PC1 wants to send data to PC8, it broadcasts the data to all the connected devices. So there is a lot of traffic. So for overcoming this problem, we are going to use a networking devices called as bridge. So let us see how this problem is being solved by using a bridge. So the same a scenario where when we are using a bridge over here, so it will identify. So whenever PC1 is sending some data, it will go and check. There is two segments. A bridge will be basically dividing it into two segments, segment 1 and segment 2. So it will check where is the device. So if the device is segment 1, it need not send the data to the other segment. So here in this segment alone, if a single data is passed to PC2, only these two devices will be processing the data instead of 6. So we in case because we are reducing the processing that is happening on the remaining 4 devices. So that is one of the advantage of going for a bridge. So diagram of a bridge. So here we can see a network where we are having wireless access points are here. So we are creating a wireless bridge link between the various devices. So in this wireless access point, we are connecting some 3 devices. Likewise, in the other also we are having many devices. So you can connect. So bridge operates at the data link layer. It is used to divide a larger network in smaller network segments. So without segmentation, all these nodes will share same collision domain that will bring down the overall network performance. To run a network smoothly, we should not place more than 20 nodes in a collision domain. So to deal with this situation, we are going for bridges. The basic function of the bridge, so it breaks a large network in smaller segments. It will join different media types such as UTP with fiber optic, join different network architectures such as Ethernet with token ring. So in bridges also there are 3 different types of bridges. One is called as your local bridge. So local bridge means this bridge connects 2 LAN segments directly. So in Ethernet implementation, it is taken as a transparent bridge. In case if you are using it in a token ring network, we call it as a source routed bridge. So this is again a sample network diagram. So then we are also having remote bridge. So remote bridge is like this bridge connects with another bridge over the WAN link. So we are having a bridge over a WAN link. Then we are also having wireless bridge. So this bridge connects with another bridge without wiring between them. So we are having 2 different segments over the wireless. So bridges also having some issues. So bridges have limited ports. So this is one of your limitations of your bridge. So in a bridge, forward decisions are made through the software, which slow down the overall performance of the network. And bridges use the age-old technology, which is not capable to fulfill the requirements of the modern networks efficiently. So in order to overcome this, only we are going for switches and routers to solve these issues. So additional information about bridges. So a bridge examines each message on a LAN and passes the ones known to be within the same LAN. So computer addresses have no relationship to location in a bridging network, and a bridge is sometimes referred to as a router. So wireless network bridges can cost anywhere between $100 to $1,000 depending on what type of bridge you are processing. Now let us look at the working of a repeater. A repeater is a network device that operates at the physical layer. So its job is basically to regenerate the signal over the same network before the signal becomes too weak or corrupted, so as to extend the length to which the signal can be transmitted over the same network. An important point to be noted about repeater is that they do not amplify the signal. When the signal becomes weak, they copy the signal bit by bit and regenerate it at the original strength. So it is basically a two-port device. So for example, I am a person A standing a PC1. Let us take PC1 and there is PC2. So if we know in computer networks, the data will be transmitted in the form of zeros and ones. So as and when my signal transmits over a long distance, the signal strength might degrade. So when it degrades, you will not be able to identify whether it is a 0 or 1. The signal strength will be weak. So in that case, we can go for a repeater. So basically, it will regenerate the signal and give you. So that is the main idea of going for a repeater. Now we are going to look at the next networking device is called as the router. A router is nothing but a specialized computer program to interface between different networks. So it is basically a layer 3 device. It works on the network layer. So how does a router work? A router will receive the data from the user, looks for the remote address of the other computer, making routing decisions along the way. It will be forwarding the user data out to a different interface that is closer to the remote network. So this is an example diagram of a router where we are having a router. A router is basically used to connect to a number of devices, like we are having a PC, laptop, tablet, etc. So likewise, you can connect a router in a network. So router is a layer 3 device that operates at the network layer, which forwards the data packets from one logical network segment to another. A router forwards the packets based on the basis of the destination address. So for this, the router keeps a record of the path that packets can use as they move across the network. So these records are maintained in a database table known as your routing table. Routing table can be built either statically or dynamically. So this is again a diagrammatic representation of how a router works. So a router can be connected to a network. So you might be having packets that are moving in and out of the router. So it depends on the different logical networks. Say for example, if someone is transmitting some data to a PC that is connected to this network, so this router will be forwarding the data to this particular network if it matches the destination address. Routers. Basically, routers are used to connect different network segments, to connect different network protocols such as IP and IPX. So to connect several smaller networks into a larger network, we can use a router. To break a large network into smaller networks also, we can use routers. If you want to connect two different media types such as UTP and fiber optical cables, you can use a router. To connect two different network architectures such as a token ring and Ethernet, if you want to connect a LAN network with the telco company's office, you can connect using a router. Also, if you want to access the DSL services, we can use the router. So now let us look at the additional information of routers. So routers make sure data sent over the internet goes where it needs to go and not where it is not needed. So it acts like a traffic controller working to cut down the congestion throughout the network and keeps everything flowing smoothly. Routers are the only type of equipment that looks at every single packet passing by on the network. So home network router includes wireless routers, which can cost anywhere between $40 to $150 or higher. So now let us look into the next device, which is called as the gateway. So as I told, gateway, it works on the top 4 layers. It is basically a communication device that provides a remote network with connectivity to the host network. So how a gateway works? The gateway node acts like a proxy server and firewall. The gateway uses forwarding tables to determine where exactly the packets are to be sent. So coming to gateways, so gateway, as the name suggests, it is a passage to connect two networks together that may work upon different networking models. They basically work as a messenger agent that takes data from one system, interpret it and transfer it to the other system. So gateway are basically called as protocol converters and can operate at any network layer. So gateways are generally more complex than the switch or a router. So next we are going to see the next device is called as a router. So it is also known as a bridging router. It is basically a device which combines features of both a bridge and a router together. It can work either at the data link or at the network layer. So working as a router, it is capable of routing the packets across the networks, and working as a bridge, it is capable of filtering the local area traffic. So now let us look at the additional information about gateways. So on the internet, a node or stopping point can be a gateway. The computers controlling the traffic within a network are gateway nodes. A gateway is also associated with the router. Thank you.